Yeah, I hate to tell you, but I won't fit in your box. I know you wanna know, but you cannot pick my locks. See, you a part of me, like New York is to the Bronx. And everything is everything, we do not need to box. Cause I could stick and move, I am focused like a soldier. And you've been in my way, heavy like a boulder. And everybody's scared of death and getting older. When you release your fear, come cry on my shoulder. Cause finally the earth's come around. Use a new part of your brain, make a new sound. All we want is love, it's making our heart pound. The new children are here, they are coming out the ground. Stop medicating them, their power will abound. Now please just gather round, the pitch is at the mound. Catch my words, don't clown, you know you like my sound. Now give your girl a pound or a hug would mean you're down. And with the power of Isis, I will speak to your third eye. I'll be your soldier in crisis, I will lick your cheek when you cry. And with the power of Isis, I will speak to your third eye. I'll be your soldier in crisis, I will lick your cheek when you cry. Down is the four rivers, the waters they will heal. I will lift my hands up to the sky and make it real. I'll make it real. My brothers and my sisters, you will see how I feel. I will give you $1 to listen. Baby, let's make a deal. No, you can't buy me, don't even try me. In fact, unleash your lasso and please untie me. I'm done with the cowboys, they do not excite me. Don't need your opinion, please don't indict me. I won't do your homework, do not assign me. The universe will teach you what science is finding. Open up your chakra, your aura could be blinding. Grab some rose quartz and start reminding. And with the power of Isis, I will speak to your third eye. I'll be your soldier in crisis, I will lick your cheek when you cry. And with the power of Isis, I will speak to your third eye. I'll be a soldier in crisis, I will lick your cheek when you cry. I am a writing machine and this is my weapon. Fighting with my mouth, peace I will be repping. We're all contradictions, stop your suggesting. The righteous do not judge cause they know it's projecting. And just cause I say it's the age of feminine doesn't mean that I am not down for a man. We all need some yang, get that dick up out your head. Cause there are mad women who are too masculine. And yes, I know that I do not sound Caucasian, but sorry, this is how it comes out like the days in. My soul is here for some consciousness raising. Stop all your labeling, I'm Kelly, amazing. And I'm not concerned with which God you're praising or what herb you're blazing. Your light shines, it's phasing, and now the birds fade in. And now the birds fade in. La-dee-da-da-da-da-day. You can light your own way. La-dee-da-da-da-da-day. Today could be your day. La-dee-da-da-da-da-day. I will be lighting my own way. La-dee-da-da-da-da-day. Today is my day. And with the power of Isis, I will speak to your third eye. I'll be a soldier in crisis, I will lick your cheek when you cry. And with the power of Isis, I will speak to your third eye. I'll be a soldier in crisis, I will lick your cheek when you cry. And with the power of Isis, I will speak to your third eye. I'll be a soldier in crisis, I will lick your cheek when you cry. And with the power of Isis, I will speak to your third eye. I'll be a soldier in crisis, I will lick your cheek when you cry. And with the power of Isis, I will speak to your third eye. I'll be a soldier in crisis, I will lick your cheek when you cry.
Hey everyone, ready for another deep dive? This time, we're tackling something we all experience every single day. Gravity.
Gravity.
You know, that force that keeps our feet on the ground.
Yeah.
But get this. The stuff you sent me.
Okay.
It hints that maybe, just maybe, our understanding of gravity is, well, a little off.
Interesting.
We're talking about a physicist who's basically challenging everything we thought we knew about gravity.
Really?
And hold on to your hats, because this deep dive also leads us to density, buoyancy, and even, wait for it, the flat Earth theory.
Wow, that's quite a range.
I know, right?
Yeah.
Sounds wild, but that's what we do here. Explore the unconventional.
Right.
The stuff that makes you go, huh, never thought of it that way.
Well, I do enjoy a good challenge, and it's definitely fascinating how something so fundamental to our lives, I mean, gravity's always there, right?
Yeah.
But it still holds so many mysteries.
Absolutely. I mean, we all learned about gravity in school. Apple falls from the tree, Newton figures it out.
Right.
But from your notes, it seems there's way more to this story.
Yeah.
We've got this physicist, Eric Verlinde, who's saying gravity might not even be a fundamental force at all. It's like finding out the Earth isn't flat after all those years thinking it was.
Haha, yeah, a bit of a paradigm shift. So, about Verland, his theory, entropic gravity, it suggests gravity isn't a force in the traditional sense, but more like an emergent phenomenon.
Emergent phenomena. Okay, break that down for me.
Think of it like temperature. Temperature isn't a fundamental property of individual atoms. It's what happens when you have a ton of atoms moving around, creating this overall effect.
I see. Like a side effect almost.
Exactly. Verlin says gravity is similar. It emerges from these tiny microscopic changes in information about where particles are.
So instead of some invisible force pulling everything together, gravity is more like a consequence of something else happening on a super small scale.
Precisely. He ties gravity to changes in entropy. Basically, how much disorder there is in a system.
Okay, so the more chaotic things get at the tiniest level, the more gravity we experience on a big scale.
You got it. And it's not just a cool idea. Verlinde highlights how when you apply Einstein's theories to extreme scenarios, black holes, galaxies, things like that, the math gets messy.
Messy how?
It's like trying to squeeze a square peg into a round hole. Sometimes you need a whole new approach. Verlinde thinks his theory can handle those inconsistencies.
So Einstein's theories, while super successful for most things, might need a little tweak when we're talking about the really big stuff.
Right. And you can imagine this has stirred up quite a bit of discussion among physicists. Sean Carroll, another physicist, calls it provocative, which in science speak.
Means it's got people talking.
Exactly. But needing more evidence.
Yeah, I bet. It's not every day someone tries to rewrite our understanding of how the universe works. So where does that leave things? Are scientists scrambling to test Verlinde's theory?
There are definitely efforts to see if his ideas hold water, but one of the biggest hurdles is making it all mesh with what we know about quantum mechanics. The world of particles acting like waves.
Quantum mechanics, always adding another layer of complexity.
Exactly. If gravity emerges from these tiny changes in information, how do you fit in the wave-like behavior of particles? It's a real head-scratcher.
It seems like every time we answer one question, 10 more pop up.
That's the fun of it, right?
True enough. Speaking of questions, some of the other material you sent me explores different ways to look at how objects interact, specifically density and buoyancy. Could you give us a quick rundown on those?
Sure thing. Density is basically how tightly packed matter is in a certain space. You calculate it by dividing an object's mass by its volume. Imagine a bowling ball and a beach ball.
Okay, got it.
Same size-ish, but the bowling ball is way heavier because it's got more mass packed into that space.
So the bowling ball is denser, which is why it's so hard to throw, right?
Exactly. Now, specific gravity is a bit different. It's about comparing an object's density to the density of water.
Okay.
If something's denser than water, specific gravity greater than 1, it sinks. Less dense, less than 1, it floats.
Makes sense. Rock sinks, feather floats. Simple enough.
Mm.
But how does this tie into the whole gravity debate? And what about the flat Earth idea that keeps popping up?
Now that is where things get really interesting. We can look at how gravity, density, and buoyancy could potentially work, both on a spherical Earth, the globe we all know,
Yeah.
and on a flat one, although, as you can imagine, things would have to work very differently in each scenario.
All right, let's unpack that. Starting with the globe, we've got gravity pulling everything towards the center, right? Like a giant magnet.
Exactly.
So density would explain why some things sink or float within that gravitational field.
Hmm.
A boat, for example, is less dense than water. So even though gravity is pulling it down, the water pushes back up, keeps it afloat.
Right, it's all about the interplay of forces.
But on a flat Earth, where they often reject the whole idea of gravity, how could density and buoyancy alone explain things staying put? It's hard to imagine how things would stick to a flat surface without some force pulling them down.
Well, flat Earth proponents might say objects just settle based on their density, heavy stuff down, light stuff up.
Okay.
But when you try to scale that up, explain how planets and stars move, it gets really complicated, and it often clashes with a lot of established scientific principles.
Sounds like trying to force that square peg into the round hole again.
Pretty much. There are a lot of unanswered questions and inconsistencies when you try to apply these concepts to a flat Earth model.
Definitely a lot to think about. Speaking of things to think about, one of the sources you sent me, planetruth.info.
Yeah.
They're firmly in the flat Earth camp,
Yeah.
and they go so far as to claim that satellites, say they're a hoax, possibly just balloons floating around up there. Okay, but wouldn't there be evidence of these fake satellites, these so-called balloons? And what about all the tech that relies on satellites? It would take a massive cover-up to make that work.
You're right to be skeptical, and here's a little wrinkle. NASA has publicly documented contracts for buying huge amounts of helium.
Helium.
Yeah, it's essential for all sorts of space programs, purging hydrogen systems, pressurizing fluids, cooling things down, even welding in space.
So on one hand, you have this claim that there are no satellites.
Right.
And on the other, NASA's buying tons of helium, a substance they need for satellites.
Right.
Seems a bit contradictory, doesn't it?
It does raise some eyebrows, to say the least. And let's connect this to something tangible. The International Space Station, a project involving multiple countries, relies heavily on helium. Saying it's all fake would require a level of global coordination and secrecy that's almost impossible to imagine.
Wow. We've covered a lot of ground already. This whole discussion reminds me of that Third Eye Blind lyric, "The universe will teach you what science is finding." Maybe, like Verlin suggests, we don't have the whole picture when it comes to gravity.
It's a thought-provoking idea, for sure. Science is all about constantly learning and refining our understanding. What we believe today might change tomorrow.
So we've established that gravity might be weirder than we thought, but why should we even care? I mean, gravity's just there, right? It's like background noise. But for the universe, does it really matter if it's a force or something else?
You know, that's a really good question, and it gets at why we even bother exploring these, well, kind of abstract ideas. Imagine finding a hidden key,
Okay.
and that key unlocks a whole new wing of this giant, mysterious mansion.
Ooh, I like that. So what kind of doors could this new understanding of gravity open? What mysteries could it help solve?
Well, for one, if Verlin's right about this whole entropic gravity thing, it could revolutionize how we think about the universe expanding. Might even shed light on dark energy.
Dark energy?
Yeah, that mysterious force that seems to be pushing everything apart faster and faster.
That's like the ultimate cosmic riddle, isn't it? So for Lynn's theory, it could give us a new angle on that.
Exactly. It could help us connect gravity, entropy, this whole idea of disorder, to the large-scale structure of the universe, like finding the missing piece of a giant puzzle.
It's kind of mind-blowing. Something as, I don't know, basic as gravity could hold the key to these huge cosmic mysteries. But hey, what about those other alternative theories we talked about? You mentioned MOND, right?
Oh yeah, MOND. Short for Modified Newtonian Dynamics.
Etchy.
It's an approach that says, instead of completely overhauling gravity, maybe we just need to tweak Newton's laws a bit.
So instead of rewriting the rules, MOND is more like fine-tuning them to better fit what we observe.
Right. You see, the way galaxies rotate, it doesn't quite line up with our current understanding of gravity. MOND proposes that gravity acts a little differently over really long distances, and that could explain those weird rotations.
So we've got Verlin saying gravity is an emergent thing, MOND suggesting we adjust the rules. It's like everyone's looking at the same elephant but from different sides, trying to figure out what it really looks like.
That's a great analogy. And it's important to remember, science isn't about finding one single right answer. It's about exploring all the options, testing different ideas, always refining what we know.
So for our listeners out there, why should they care about all these different gravity theories? What's the takeaway?
It's about opening our minds, questioning what we think is true, and realizing there's always more to learn. It's about that sense of wonder, that curiosity about the universe and our place in it.
Like when you look up at the stars and realize just how vast and mysterious everything is.
Exactly. It's that feeling of being part of something much bigger than ourselves, something we're just starting to grasp. And hey, maybe someday one of our listeners will be the one to make the next big discovery about gravity.
Now that would be cool. Okay, we can't forget about those flat Earth claims. In the last part, we touched on their skepticism about satellites. What other interesting or maybe just plain strange things do they say about gravity and, well, the shape of the Earth?
Oh, there are plenty. One of their big ones is that if Earth was really a sphere, we should see a curve when we look out over long distances, right? So they point to long bridges or canals that look straight as proof.
But wouldn't the curve be too small to see with just our eyes over those distances?
The Earth's curvature is gradual. Over the distances we usually see, we wouldn't easily notice it.
But what about those classic examples like ships disappearing hull first over the horizon? That's often used as evidence for a curved Earth.
They tend to explain that away as just perspective and the atmosphere messing with how we see things. So as a ship sails away, it looks like it's sinking below the horizon, but it's just an optical illusion, not because it's going over a curve.
But wouldn't that mean if we had strong enough telescopes, we could still see those ships,
Yeah.
even after they've supposedly vanished?
That's a thing, yes.
It sounds like approaching these conversations with an open mind is key. Being willing to question our own assumptions and admit when we might be wrong.
Couldn't have said it better myself.
Mm.
It's all about being open to learning, to new ideas, even if they challenge what we thought we knew.
Okay, so we've really gone deep on some mind-bending gravity stuff. Entropic gravity, MOND, even touched on the flat Earth perspective.
Definitely covered a lot of ground.
But now I'm thinking, what's the big picture here?
That's the question, isn't it? Where do we fit in this whole grand cosmic scheme? And does our understanding of gravity change how we see ourselves in the universe?
It's humbling, right? That we're just this tiny part of something so vast and mysterious.
It is.
But also exciting, like we're standing at the edge of the unknown, looking out into the cosmos. Who knows what we might find next?
Exactly. That's what's so amazing about science. It's this never-ending journey. We might never have all the answers,
Right.
but it's that pursuit of knowledge, the search, that drives us. It pushes us to question, to test, to push beyond what we thought we knew.
It's like climbing a mountain, right?
Yeah.
The higher you climb, the more you realize how much further there is to go.
Yeah.
But the view from the top, that makes it all worth it.
And sometimes it's not even about reaching the summit. It's those unexpected things you discover along the way. New perspectives, connections, moments that remind you just how incredible the universe is.
Totally. Those aha moments when things click into place and suddenly you see the world differently. I think that's what we tried to do here,
Yeah.
Spark that curiosity, encourage people to keep exploring these mysteries.
It's all about that sense of wonder.
Yeah.
Because ultimately, we're all explorers. We all have that drive to learn, to understand our place in everything. And whether we're thinking about gravity or just looking up at the stars, we're all connected by that shared sense of awe.
Couldn't have said it better myself. And to our listeners, we hope this has left you with more questions than answers. Because that's the heart of science, isn't it? So keep questioning, keep exploring, and keep looking up at those stars. Who knows what amazing discoveries are still out there?
The universe is full of possibilities.
Until next time, keep diving deep.